ADA Accessibility Lift Guide, which lift fits your building. Hook when a building needs wheelchair access between different levels. The first question is often, which accessibility lift should we install? But that may actually be the wrong place to start. An ADA accessibility lift is not one specific type of equipment. Depending on the building, accessibility may be provided by a passenger elevator, a LULA elevator, a vertical platform lift, or an inclined platform lift. And these systems are designed for very different situations. So instead of asking which lift is best, the better question is, which accessibility solution fits this building, its users, and its expected traffic? Let's break it down. Start with travel height and passenger traffic. Travel height is one of the first factors that narrows the options. For a short level difference at an entrance, mezzanine or split level area, a vertical platform lift, or VPL can often provide accessibility without the structural requirements of a conventional passenger elevator. For a low-rise building with moderate traffic, a LULA elevator may provide a useful middle ground. It offers enclosed vertical transportation while typically requiring less space than a conventional passenger elevator. For buildings with multiple occupied floors and continuous passenger traffic, a passenger elevator usually becomes more practical. And if the main barrier is an existing staircase that cannot easily be replaced or bypassed, an inclined platform lift may be considered. So the basic logic is not simply about equipment size. It is about matching travel height and usage with the right transportation system. Why passenger traffic matters. This is one factor that is easy to underestimate. Imagine a community building where a wheelchair user needs the lift only occasionally. A VPL may work perfectly well. Now, imagine a hospital, hotel, office building, or public facility where people are moving between floors throughout the day. The situation changes. Higher traffic means more operating cycles, more door operations, longer waiting times, greater component wear, and higher maintenance demand. A platform lift can remove an accessibility barrier, but it is not automatically a substitute for a passenger elevator. When traffic becomes continuous, passenger throughput becomes part of the accessibility problem. Existing buildings change. The decision. Retrofit projects are where equipment selection becomes much more complicated. Before choosing a lift, engineers need to understand what the building can physically accommodate. Is there an existing shaft? How much pit depth is available? Is there enough overhead clearance? Can the structure support the equipment? Where can the doors be located? Suitable electrical infrastructure available? And can maintenance personnel actually access the equipment later? Take pit depth as an example. It may seem easy to say, we'll just excavate deeper. But underneath an existing floor there could be foundation beams, waterproofing, drainage systems, plumbing, or electrical conduits. Moving those systems may cost much more than selecting a lift designed for shallower installation conditions. The same applies to overhead clearance. Modifying a roof structure just to fit a preferred elevator configuration can significantly increase project complexity. That is why retrofit accessibility planning should usually begin with the building, not the equipment catalog. LULA or vertical platform lift. This is a common comparison. A vertical platform lift is generally well suited to shorter travel distances, relatively low accessibility traffic, and projects where minimizing structural modification is important. A LULA elevator is more appropriate when a low-rise building expects more regular passenger use and needs enclosed vertical transportation, but cannot easily accommodate a conventional passenger elevator. Neither is universally better. If the building has very low traffic and major structural limitations, the simplicity of a VPL can be valuable. If usage is more frequent, the additional transportation capability of a LULA may make more sense. And if passenger demand continues increasing, the project team should also consider whether a conventional passenger elevator would provide better long-term performance. Accessibility is more than platform size. Another mistake is focusing only on whether a wheelchair physically fits inside the lift. Real accessibility includes the complete journey. Can the user approach the entrance easily? Is there enough maneuvering space? Is the door opening appropriate? Can the controls be reached independently? Air braille and tactile markings provided. Are there audible and visual travel signals? Is emergency communication accessible? Does the lift level accurately with the landing? And after exiting, can the user continue through the building without encountering another barrier? A lift can operate safely and still provide poor accessibility if these surrounding conditions are ignored. That is why mechanical safety and accessibility performance are related. but they are not the same thing. Think beyond installation day. Accessibility should also be considered throughout the equipment lifecycle. Door sensors can deteriorate, floor leveling can change, voice announcements can fail, tactile controls can wear, emergency communication systems can become outdated. Replacement parts may become difficult to obtain. These issues may not immediately stop the lift mechanically, but they can reduce independent usability. So long-term planning should consider maintenance access, spare parts, modernization compatibility, technical support, and how the building may be used in the future. Conclusion. So, which ADA accessibility lift fits your building? There is no single answer. A passenger elevator may be appropriate for high traffic and multiple floors. A LULA elevator can work well in low-rise buildings with moderate traffic. A vertical platform lift can solve short accessibility barriers while minimizing structural modification. And an inclined platform lift can provide access where an existing staircase remains the only practical route. The keys to evaluate: building conditions, FE accessibility objectives, FE travel height, FE passenger traffic, FE structural constraints, FE long-term operation. Accessibility is the outcome. The lift is the engineering solution used to achieve it. For more details about choosing accessibility lift solutions for different buildings, you can refer to the original article here. https://ecnilift.com/ada-accessibility-lift-guide/